I've used the toList execution method enough. Let's take a look at some more LINQ execution methods, which not only trigger the execution, but they also constrain the SQL query with some means of aggregating, such as first or max. Here's a list of all the execution methods. And keep in mind that the EF Core specific methods are a subset of .NET's LINQ methods. And each of these methods does have an asynchronous counterpart. Note that toList also has an asynchronous counterpart, and all of them, except for toList and asEnumerable, perform some type of aggregation when they execute. And the logic of the aggregation, first or max or count or average, are incorporated into the SQL that's sent to the database. I won't demonstrate every one of the methods, but there are some LINQ courses on Pluralsight where you can dig deeper into constructing queries. I want to focus a little more on this group of methods that have an OR default option, and I'll use first and first-or default to explain an important point. First, we'll simply look for the first occurrence. If there's no result from the database, in other words, the query couldn't even find one matching row, then it will throw an exception. That can be useful in a limited number of scenarios. First or default is a safer way to seek the first occurrence. If there's no result, this method will return null, unless you have a very special default specified for your type. And I've never seen anything but null coming back. But you can look at the Microsoft docs about first or default to explain this in more detail if you're interested. And it is a lot easier to check for null than to handle an exception. So it's much more common to use the OR default methods for first, single, and last. Now let's get back to some code. I have a query that looks for all authors whose last name is Lerman. Now I just want to get the first one found in the database, so I'll change the execution method from toList to first or default. If I hover over the return variable, authors, you can see that the compiler knows the result will now be a single author object, not a list of author objects. So I'll change the variable name to reflect that. And I can make my expression a little more efficient because you can use the predicate that we're using in the where method directly as a parameter of first or default instead of using this combination of where and first or default. And you can do that with all of the aggregate execution methods, but not with toList. When I debug this, you can see that the result is a single author. And looking at the SQL, the way the EF Core resolves a first or default LINQ method is by using select top 1 in the SQL query. Now I'll combine this with another LINQ method, order by descending, which you just learned about. So I want to filter on Lerman's, sort by the first name in descending order, and then get the first one in that group. And that's exactly how the LINQ query is translating it into SQL. It applies the filter before it applies the ordering. And this time the result is Rhoda Lerman, because Rhoda comes first in the reverse sort order. I want to make one more point about the aggregates, and that's about the last and last or default methods. These methods will only work if you first sort the query using one of the order by LINQ methods. Otherwise, it has no context for determining what's last. And if you don't use order by in the LINQ query, the compiler can't warn you because query translation happens at runtime. So it's at runtime that an exception will get thrown because EF Core cannot work out that query. You've learned about how EF Core tracks objects by default, but not every scenario requires that we keep track of the state of these objects. For example, if you're presenting something for display only and the user won't be editing, there's no need for EF Core to waste its time and resources creating those little tracking objects, the entity entry objects, to manage the state of the query results. While tracking is efficient, when you don't need it at all, it is definitely a resource and performance cost that you don't need to be paying. While it wouldn't be noticeable with the small work we're doing so far in these demos, in a heavily trafficked application with a lot of data, performance will definitely benefit from disabling the tracking when you don't need it. The most common scenario in which the default tracking is a waste is web and mobile applications. And we refer to these as disconnected apps because the application or web browser running on your computer or device is disconnected from the server that's performing the back-end tasks of retrieving and storing data and probably other functions as well. You'll learn a lot more about using EF Core in web apps later on in this course. EF Core has two ways to avoid tracking when it's a waste of resources. You can use no tracking queries or no tracking DB contexts. And this is a really important pattern to use when building websites or web APIs, for example. In fact, the examples I'm about to show you will be used later in the course when you learn how to use EF Core in an ASP.NET Core API. The first way we've had since the early days of Entity Framework, and that's to specify that a particular query should not bother tracking its results. This is the dbSetAsNoTracking method. Appending this to a dbSet in a LINQ query will ensure that the DB context doesn't create entity entry objects to track the results of the query. This is useful when, by default, you do want tracking, but on certain occasions it's not needed. Be aware that the AsNoTracking method returns a query, so you can't append dbSet methods such as find to AsNoTracking. However, you can still use LINQ methods. The other way is one that can be applied to a DB context to ensure that by default, any query executed by that context doesn't track. You can configure the DB context tracking behavior in the onConfiguring method where we've already applied the use SQL Server method. Another one of the options builder methods is use query tracking behavior, and that can be set to one of the query tracking behavior enums. There are three of those. The default is track all, and there's also no tracking, and another one for more advanced uses, no tracking with identity resolution. If I were to make that change to the pub context, every query from pub context would be a no tracking query by default. And that's great in the apps where this should be the default, and you won't have to worry about remembering to specify it on every query. And when no tracking is your default, and you have a special case where for some reason you do want to track a special query, the dbSetAsNoTracking method has a counterpart, AsTracking. So when the default is no tracking, as per the DB context, you can still specify that a particular query should track its results with the AsTracking method. We'll take a closer look at disabling tracking when you learn about logging with EF Core and when we work with the ASP.NET Core API later on in the course. My goal with this module was to provide you with some really useful basics about querying with EF Core, enough to get you querying productively. You learned how to express queries using LINQ against simple types that can filter, sort, and even aggregate data. You learned the difference between writing a query and executing it. And you need to use one of the execution methods like toList or even first or default to trigger EF Core's query workflow of transforming the LINQ into SQL, sending it to the database, and then materializing the database results into objects. And EF Core, along with the database provider, is able to translate all of that into SQL that gets executed on the database. And that means the database gets to do what it's really good at. And EF Core acts as a mediator between your application and the database. Understanding the workflow and the little bit about how EF Core is doing its job is really important, something I believe for any tool you use. And along those lines, understanding that the default behavior, especially in this case, of creating tracking objects for each of the results from the query, may not always give you the best performance. And that's powerful knowledge which you can benefit from in so many of your apps. After all of this work with querying, next you'll learn more about tracking changes and saving data back to the database. Here are some resources I mentioned in this module, as well as a few other relevant links I think you might find useful. I'm Julie Lerman, and thanks for watching Entity Framework Course 6 Fundamentals. Hello, this is Julie Lerman. Welcome back to Entity Framework Course 6 Fundamentals. This module will dive more deeply into tracking and saving data with EF Core. We'll start by digging into a deeper understanding of the DB context and entity with respect to EF Core's tracking. Then, like with the querying module, I'll provide you with an overview of EF Core's tracking and saving workflow to empower you with a better understanding of what EF Core is doing on your behalf. Then you'll learn the basics of inserting, updating, and deleting data using EF Core, and the data model that we created earlier along with the SQL Server database. We'll continue our focus of working with simple types with these early lessons. Then you'll learn about tracking and saving multiple objects at a time, so for example, a handful of authors. You'll learn about EF Core support for bulk operations, which enhances performance when you're saving a bunch of data. Along the way, I'll provide some insight into how persistence is different in disconnected apps like web applications. I'll continue to use the SQL Profiler to provide you with some insight into the SQL that EF Core is sending to the database. So let's get started. I've already mentioned tracking a few times in the earlier modules. It's time to get a better idea of what that is and how it relates to saving. I found that in my years of working with EF and EF Core, understanding this has made life a lot easier, especially when things don't work the way you expect. Learning this early on will make you much more productive, and it will hopefully avoid a lot of the "but why" and "but how" questions you might have as we move forward. The documentation's definition of the DB context is that it is a representation of a session with a database. And that session begins not when the context is instantiated, but the first time you ask the context to do something with the database, execute a query or save some data. But the DB context does more than just interact with the database, and its change tracker is a critical piece of that. I've talked about the little tracker objects already, and they're called entity entry objects. And it's the change tracker that manages them. It creates them and maintains their value. It's the entity entries that know about the state of your domain object. And in more advanced use cases, you can actually interact with those entity entry objects, but you shouldn't need much more insight into them right now. Now I think it will make sense for me to finally explain what an entity is. Entity is one of those overloaded terms that's used throughout software and in a lot of other industries. But within the context of EF Core, it does have a particular meaning. A running application has objects in memory that you're working with. When the DB context is aware of one of those objects, in other words, it has had some reason to create one of those entity entry change tracker objects, then we refer to that in-memory object as an entity. There's another critical aspect of an object required for it to be an entity and for EF Core to be able to track it. It must have a key property. Recall the author has one called ID, and the book has one called book ID. That identity property is pretty important for storing data in the database so that you can identify one from another. And terminology is important. So when I'm talking about an entity, I'm talking about an in-memory object with a key that the DB context change tracker is aware of. The DB context isn't literally managing your domain objects like the authors and books. It just takes a look at them and puts relevant info into those entity entry objects.